Hello everyone, it's time for class again. This is ECE341, the probability and the random process course. Welcome. Okay, ECE341. This is the lecture for the 7th week, Friday's class, right? Okay, today we will consider some function of random variable, right? We already studied something about the random variable. We have the definition of random variable. We have the CDF, PMF, PDF of a random variable. Now we consider a function of random variable, right? Or function of a random variable. It is still a random variable. Yeah, the function of a random variable. It is still a random variable. And then we can also have those functions, the CDF, PDF, or PMF. And we can also have like the mean, the variance, the standard deviation. We can have all of those. Let me use an example to explain it. Suppose we have a random variable x has PDF. So this is a continuous type, right? Fx of x, which is some k and 0. Here, if f value of x smaller than, like I suppose this is 2, all right? And if f value of x larger than 2, and you put the equal somewhere. I have 2. It doesn't matter. I put it here is fine. Put it in this part is also fine. Okay. Now y equal to x squared. Then we want to know several things. Find fy of y. This is a PDF of y. I also want, for example, I want the fy of y. This is a CDF of y. And E of y, variance of y, right? And if also like a standard deviation of y. Actually, this is a square root of variance of y. So if you have variance, then you can have delta y. Just take a square root. Okay. Solution. First one, here I said I want to find the PDF. But actually, this is not so easy to find it directly. This is the density, right? It is a limit or a derivative of fy. So we can find fy firstly. Find fy, the CDF, then take derivative, then we have the density function. So the first one, find fy of y. And what is this? By definition, this is the probability of the event capital Y smaller than or equal to lowercase y. And what is y? Capital Y. What is capital Y? Capital Y is x squared. Okay, so here's a x squared smaller than lowercase y. Then what is the value of these? I need 2 cases, right? Okay, I'm ready. It is 0 if y is smaller than or maybe equal to 0, right? If lowercase y is a negative value, square value cannot smaller than the negative value, so it's impossible. So this should be 0. If y is 0, then capital X must be 0, just one value. And this is a continuous type random variable. A single value, the property of a single value, it will be 0. So this case, we will have 0. And the second case, now if y is a positive value, then this is the probability of negative square root of y smaller than x smaller than square root of y, right? We have these. Okay. If x is a value between negative and positive square root of y, then x squared was smaller than y. Alright, then we do calculation. So I write this way, y positive. I just write this part, right? If I copy it every time, I need that line. I don't want to copy that. Okay, so what is the probability of this one? Now we know this is a integral of, because this is a probability about the variable x. So this is integral of fx of x dx, and x will run from negative square root of y to positive square root of y. Alright. Now what is fx? Oh, I have a k unknown. So before this, I need to find k firstly. Okay, I put 1 here. Now we need determine k in this fx of x. So how to do it? We can use this rule, the integral of density function from negative to positive infinite. That must be 1. So the integral, right? You look at the fx. For x large, it's 0. For x small, it's k. So we only need for small x, those from negative 2 to 2, right? Absolute value x smaller than 2. So integral from negative 2 to positive 2, and fx now it is just k dx equal to 1. So this is a k times 1, right? 1 by integral I have just x from 2 to negative 2 equal to 1. So this is k times 2 minus negative 2 equal to 1. I get k equal to, this is 4, right? 2 minus negative 2, it is 4. So the 1/4, k is 1/4. I have k now. Alright. So 1 become we know k is 1/4, so we put it in plug in 1. This is k. fx is just k. K run from negative 2 positive 2. Okay, here's a negative y to negative square root of y to positive square root of y. I need to compare these two values. So we have two cases. If y square root of y larger than 2, then fy of y will be just from negative 2 to 2, and the density function of x is 1/4, and the dx. So this is 1. This is 1, right? Negative 2 to 2, and here's 1/4. The area, right? You do integral is just the area. So this is here's 1/4, here's 4. 4 times 1/4, you get 1. Yeah, you can also use formula. So you get this result. And if square root of y is number smaller than 2, equal to is also that part, smaller than 2, then we have fy of y will equal to from negative square root of y to positive square root of y. Here's 1/4 dx. So in this case, still here's 1/4, and this is negative square root of y. Here's a positive square root of y. The area, what is the area? This area is 1/4 times 2 of that. So it is a half of square root of y. Alright, so we can have the overall result. Fy of y or equal to, we have 3 cases. If y is a negative value, it's here, right? If y is negative, it is 0. If y is positive, we have two cases, larger than 2 or smaller than 2. So, okay, 0, if y smaller than 0, it contains 0. Or this one, it is a half of square root of y if y is between 0 to 2. Okay, 0 to 2. And it is 1 if y, oh no, square root smaller than 2. Square root smaller than 2. Okay, this is a 2 square, right? It's a 4. And this one larger than 2, so y larger than 4. And put the equal here. Alright, then we have the what is this? This is the CDF. Right? This is CDF. Now we go to, I have, this is also 1. This is for equation, and I use 1 here for, I put the step 1. Okay, step 1. Then I consider the step 2. Now we can have fy of y, that is a derivative of CDF. It will be 0 if y is negative or y is larger than 4, right? 0 and 1, the constant. You take derivative, that will be 0. We can have a graph of it. It looks like this way. Here's 0, here's 1. Okay. And if it is this one, this is a half of y to the half. And take derivative, it will be 1/2, this constant 1/2. And here's the power, I move power to here, and then y of the power minus 1, right? It is this one. So it is 1/4 times is negative power. Okay, it's a negative 1/2 if y is between 0 and 4. Now we have this one. So we have the density. Oh, I have an infinite density. This density, because when y go to 0, this is a thing that looks like this. When y is 4, 4 square root is 2, and divide by 2, this is 1/8. Here's a 4. And y is 4, this is a 1/2, right? 1/2 times 1/4. This is a 1/8. When y is 4. And when y is 0, it is 0. This is 0. And this side is also density. This is 0. This is 0. And here go to infinity. This is a fy of y. Looks like this. Alright. Then we can consider the mean value. Step 3. The mean value, E of y. E of y, by definition, that is y times fy of y dy, and okay, by definition this is from negative to positive infinity, but in this example we only need a 0 to 4, so this is a 0 to 4 y times 1/8 and fy is not 1/8, 1/4. 1/4 times y to the negative 1/2 dy. So this is an integral of 1/4, a constant I moved in the front, and this one should be y. The power is 1 minus 1/2, so it's 1/2 dy. Okay, so what is this one? integral, that will be 1 over 1/2, and here is y of 1 plus 1/2, right? This one I take derivative of 3. Yeah, 1 plus 1/2 is 3. 3 over 2. 3 over 2. 3 of half. Okay. And the y run from 0 to 4. 0 just 0 and 4. So this is this one, these two I times together is 1/6, right? 4 and 2 cancel. I have a 2, 2, 3. I get 6. 6, 1/6. And this one, it is 4 to the 3 over 2 power. So this is 1/6 times, I have 1/2, it's square root, right? Square root of 4 is 2. 2 to the 3 is 8. So it's 8 over 6, which is 4 over 3. Okay, I just keep it, right? It's 1.33335. Alright, I have E. This is E. And we also want step 4. I want the variance of y. Then we have a formula. Remember last time I introduced that formula. It is E of y squared minus square of EY. Yeah. Don't flip the order. These two. This one should be in the front. And the result must larger than 0. The result must be a number larger than 0. If you get a negative number, then okay, most possibly you put the wrong order of these two. Yeah, you do calculation. Finally, you get variance is a negative. Oh, that's wrong. Should be positive. All right. Okay, so this one is we know this, right? EY is a 4 of third square. And what is this? We calculate this firstly. EY square. So this is the integral of y squared times the density of y dy, and y run from negative to positive infinite. But actually I only need 0 to 4, right? Here's y squared, and the density is 1/4 times square root of y, y to negative 1/2. I still use this, negative 1/2. It's a 1 over square root. Y, this one is 1 over square root of y. I just write this way, dy. Right? So this is I move 1/4 in the front. And here, you times these two, I get the integral of y to the 2 minus half. It's 1/5. I write this way, dy. Alright. So this is 1/4 times 2.5, 1 over 2.5. And here's y of 2.5. And y run from 0 to 4. I only need it is 4. So this is 1 over, this is 10, right? This is 10, 1 over 10. And this one, it is 2.5 is 5 over 2. So y 5 over 2, that is a square root of y with with power 5. Okay, and y is 4, right? So this is a 4 square root and 5 power. So this is 2 to 5. 2 to 5 is what? 32, right? 1, 2, 4, 16, 32. 0, 1, 2, 3, 4, right? Power 4. Oh, power 5. 0, 1, 2. Oh, I have 8. I forgot. 32, yeah, 32. So 32 over 10. So 3.2, right? 32 over 10. Okay, so we have the EY squared. Then we have variance of y will be 3.2 minus 4 over 3 squared. What is this? 4 over 3, this is a 3.2 minus 16 over 9. Yeah, if you have calculator, you can use it. And I can also write it as a fraction. Fraction, this is I just use 9. Here should be 3.2 times 9, or 9 minus 16. So 3.2 times 9 2 9 is 18, 3 9 is 27, right? 28, 1 down, so 28.8, and minus 16, so 8 to 1, so this is 128 dot over 9. And if you do not like this dot in the numerator, you put 128 over 90. Alright, and this one you can do some simplifying. Keep it this way. Yeah, keep this fine. This is good. This is also good. If you have calculator, you can have the final answer. Alright. Okay. So this is an example. When you have a function of a random variable, then how to determine the related functions and like a mean and variance and standard deviation values. Oh, this one. What is standard deviation? I didn't mention here. So standard deviation, deviation, sigma y will be square root of variance of y. So yeah, I don't know, I just put it here. Yeah, you need a calculator, of course. Now maybe computer, use MATLAB or any program in computer, you can get the value. Okay, so this is one example, and actually here we can have another way to find the variance and the mean value. If we do not want the density function and the CDF of y. Okay, I'll show it here. Method 2 for calculation of EY and variance of y. Now, suppose we do not want the PDF and the CDF. If we do not want this function, do not want these two functions, then we can calculate them directly. E of y, it is just E of x squared. You got it? Yeah, so we can calculate by x, because yeah, so this is the integral of x squared fx of x dx from negative to positive infinity. And fx we know is run from negative 2 positive 2, right? So this is a negative 2 to positive 2 x squared, and that one is what? It's a k, right? I gave it a k, and the k, what is the value of k? K is 1/4, right? K is 1/4. Okay, so this is 1/4 dx. Right? Put here fx of x equal to 1/4 or 0 if x smaller than 2 or x larger than 2. Right? We have this one. So this is 1/4 times x cubed over 3 and run from negative 2 to 2. So this is 1/4 times 2 to the 2 cubed over 3 minus negative 2 cubed over 3. So this is 1/4 times this is 8 over 3 minus a negative 8 over 3. Right? It's a plus. So this is a 2 of 8. So 1/4 times 16 over 3. And I cancel these, I get 4 over 3. Is this the right way? Right answer? We can compare the previous result. We have, you see, EY here. We calculate based on the density function of y, we get 4 over 3. And we calculate based on the density of x, it is still 4 over 3. So both methods works if you only want the mean value, the EX value, the expectation value. You don't want the density function and the CDF, then you can just calculate by this one. It's a shorter way. Okay. And similar for the EY, variance of y were equal to, okay, it is e of y squared minus ey squared, and this one we already have is 4 over 3. And what it is? This is e of x fourth. So we can calculate based on x. Right? We calculate this number based on x. Minus this is a 16 over 9. So this is integral from -2 to 2x fourth, and 1/4, that is a density function of x, that k, and the dx minus 16 over 9, which will be which will be 1/4 times x fifths over 5 from -2 to 2 minus 16 over 9. This will be 1 over 20 times 2 to the fifth. 2 to the fifth, I just got 32, right? 32 minus -2 to fifth is -32 minus 16 over 9. Okay, so this is over 20. So here's a 2. You cancel that 2, is over 10. 32 over 10. So this is a 3.2 minus 16 over 9. That'll be same answer, right? The same way that one. Where is it? Oh, sorry, I lost that paper. Yeah, you should just remember that we just finished. That will be 128 over 90. Right, we have this one. Very good. This one is not, this one is not, this one is not. Oh, it's just here. Is it here? Oh, this is master 2. Ah, I see. Yeah, so this one. Right. Okay, so we have both methods. Alright, that example is for continuous type. Now we can consider another example with the discrete type. Okay, I use square root. Okay, suppose x is described by this way. Okay, I use a PMF. X, random variable x, has probability mass function p x of x or equal to, still use a k. Here's a x equal to 0, positive, negative, just positive. I use square root. So positive 1, positive 2, positive 3, positive 4. Okay, yeah, this is x, and 0 for our other x. Okay, and let y equal to square root of x. Square root of x. Then we want to know several things. PMF py of y. We want the mean e of y. We want the variance of y. We want these three. Do we want the CDF? Okay, optional if I have time. Alright. Yeah, if I have time, I find the CDF. Optional. So first one for PMF. For discrete type, actually you just list the value, that will be fine. But you see x can has value, solution, right? 0, 1, 2, 3, 4, and the probability of this value, actually that is just this PMF. So it's the value of the probability of these numbers, they are k. They are k. I don't know what is k, but you see these 0 to 4, these 0, 1, 2, 3, 4, they are all the possible results. So the probability of all of these should be 1. So summation of k's should be 1. So 5 times k equal to 1. So k is 1/5. Yeah, we know 1/5, right? Is a 5 number. 5 of k. Yeah, you have 5. Yeah. So k is 1/5. 1/5. All right. And then I show you this table. I have x could be 0, 1, 2, 3, 4. And then what is y? Y is square root of x. So this is 0, 1, square root of 2, square root of 3, and 2. This is y. Value of y. And the probability should be same, right? When x is 0, y will be 0, and the probability is 1/5. So all of these, they have probability 1/5. Okay, now we have the PMF of y is Py of y equal to, will be k or 0, 1/5. We don't need to put k because I have the value, right? If I put k, that means I don't know, I need to find it. Now I have it, it's 0.2, 1 over 5. Otherwise it will be 0. Here for y equal to 0, 1, square root of 2, square root of 3, or 2. And for otherwise, yeah, when we say otherwise, that means all the rest value of y, right? Here I have some values of y, then all the rest is otherwise. For otherwise, the probability is 0. And for these 5 numbers of y, the probability will be 1/5. So we have the PMF of y. And then EY. What is EY? EY is a summation of y times the probability. That means Py of y, right? For all y, all of the y. But for these y's, probability is 0. This is 0, so we don't need it, right? Plus some 0, nothing. So we only need this value. So it is 0 times 1/5, right? Value times the probability, and 1 times 1/5, and square root 2 times 1/5, and square root of 3 times 1/5, and 2 times 1/5. What is this? I need 2 square root. Okay, I leave it here. All right. Yeah, if you are interested, you can calculate. Yeah, you need 2 square root. You need 2 square root. Okay, I think I know this. This is 1.4. This is 1.7. So this 2 should be 3.1 and something. And here's a 0.2, the 0, 0.2, 0.4, right? Plus 0.2 plus 0.4. So this is a this is divided by 5, right? 3.1 divided by 5. This will be 0.66, 62, right? 0.62 something, and plus another 6, so it's 1.22 something. Yeah, it's like this. Okay, so this value is fine. Yeah, 1.22, and then variance of y. We still use the same formula. E of y squared minus EY squared. Am I in the right order? Yeah, if you are not sure, just keep working. Finally, you check the answer is positive or negative. If it's a positive, you are good. If you have negative, you just change it here to negative, here to plus. That will be fine. But now I know it's good, right? Okay, so this will be E of y squared. There will be summation of y squared times the probability for all y's, and minus this one is 1.22 something square, right? this one. So this is a 0 square plus, this is a k, right? This is a 1/5, so I can move this outside. So this is a 1 square plus square root 2 square. Okay, this number is good. And square root of 3 with square, and 0, 1, 2, 3, and 4 square root 4 is 2 square, right? Times all the probability here is 1/5 minus 1.22 square. So this is 0 plus 1 plus 2 plus 3 plus 4 and 1/5 minus that, what it is. This is 1, 2 gets 3. 3, 3, 6. 6, 4 is 10. 10 over 5 is 2. 2 minus 1.22 square. Oh, I can't calculate what it is. Okay, I just leave it here. This time really leave it here. This square. And a lot of numbers after it, right? The square. It's hard to calculate. I leave it here. Okay, so I have the variance. And you can also have the square root, right? Sigma y will be square root of variance of y. It will be something. And here I said you need to check, double check, and make sure this is a positive value. Is it a positive? Yes, this is 1 dot something, right? 1.2. You take square, 1.4 square. This one is 1.4. So a number smaller 1.4, you take square. Square will be smaller than 2, right? You take square. This one is smaller than this. So you take square where smaller than some number smaller than 2. So this is smaller than 2. So this is positive, right? This is positive. It is good. It is good. Alright. What's the time? 37. Okay. I can also try to find the CDF, right? CDF. And option. CDF is what? CDF Fy of y. Actually, this is a probability of y smaller than y. So this is summation of the probability. I just say the py of I use this y, so I use another y. I use y tilde for or y tilde smaller than and include equal to y. So it's this one. Then we need a check for different value of y, right? We have, this is y. We will take 0, 1 possible value, 0, 1, and square root of 2, the 1.4, square root of 2, and the square root of 3 and 2. Okay. We have these 5 possible values. So Fy of y can equal to, it will be 0 if y is smaller than 0, right? For this side, no value, no possible. Probability should be 0, right? And when y go to here, okay, we have one possible, right? For all y tilde smaller than this y, this is y. Smaller than y with positive probability is just this 0 point. And what is the probability of this point? It is 1/5. So 0.2, okay, 0.2. If y is a value between 0 and 1, cannot equal. If it is equal to 1, you will have one more possible. Okay. And if, okay, now 1 smaller than y, smaller than square root of 2 is here. Is here. I say this is 1, this is 2, this is 3, this is 1, this is 2, this is 3. For this, we have 2 possible, right? And each with probability 0.2, so it's 0.4. And if, okay, it's here. This is a fourth. This is a square root of y smaller than or equal to y, square root of 2 smaller than or equal to y, and smaller than square root of 3. This is the first case, and here we have 3 possible, right? First case, we have 3 possibles. So the probability 3 of 0.2 is 0.6. Alright. Yeah, this is just for this example. In the midterm, when I grade, I find some people work like this. They use the result from the example or homework. You can use a method. You cannot use the same number. Here, each one I have probabilities 0.2. Maybe some other problem, each one has probabilities not 0.2. Then you need to use that number, not use this 0.2. Alright. Yeah, you cannot mix the problems. You work on different problem. You need to use different numbers. Alright. Here's 0.6, and then this one here. Right here, here's a fifth case. If square root of 3 smaller than y, and y no more than what is this value? 0, 1, square root 2, square root 3. Oh, this is square root of 4. This is 2. Okay, smaller than 2. This is the fifth case, and here's I have 1, 2, 3, 4. 4 point, right? This is larger, smaller. This one is smaller than this value. To be, I have 4 possible. So each is 0.2. So it's 0.8. And the last one, if y is here, this is 6th case. Y is larger than 2. Then it contains all the possible results. So actually, this should be the 100% whole sample space. Right? It's 1 if y is larger than or equal to 2. Okay, we have, this is the CDF. If you want a graph of CDF, then you can have the graph will be 0.2, 0.4, 0.6, 0.8, it's 1, right? 1 is 0.2, and start from 0. So this is a still like this, and here's 1, and then square root of 2, square root of 3, and 2. So it's like this. Like this. Alright. Yeah. And this is the fy of y. This x-axis is y. Right. Here we have this. Okay. Alright, that's all for today. And then see you next time. Actually, it's Friday today, right? So have a good weekend. Bye bye.